perfect 4K video signal across distances you'd normally drive. We're talking 20 miles.
Yeah, and the engine, so to speak, is this one piece of gear, the Kramer F676-IN2-F16 fiber optic input card. I mean, at its core, this thing is a modular component built for one job ultra-reach extension of HDMI signals, and crucially, it's pushing 4K at 60 Hz. But, and this is important, at 4.2.0 chroma subsampling. It slots into Kramer's big VS1616 DNEM matrix, so it's a hub for these huge installations. So yeah, there's a lot to unpack there.
Okay, so the first thing that just jumps off the page at me is the range. You've got two kinds of fiber optic runs here, and the difference is, well, it's just staggering.
It really is. So with your standard multi-mode fiber, you know, the OM3 compliant stuff, you're looking at a max of 3 kilometers.
About 1.8 miles.
Which is already pretty far.
Right, but it's not the main event. No. Because then you switch to single-mode fiber, the OS1, G.652D compliant type, and this card gets what they call ultra-reach extension. We're talking up to 33 kilometers. That's 20.5 miles.
It's an enormous distance.
Before we get into the tech that makes that happen, I have to point out this card that can throw a signal basically across a city. It weighs 0.2 kilograms. It's just immense power in this tiny little package.
It is a powerhouse for sure. And to pull off that distance, you're pushing a lot of data. It's a max bandwidth of 10.2 gigabits per second, so 3.4 G per channel, while still keeping things locked down with HTTP 2.2 and handling lossless audio like Dolby True HD.
Okay, so this is where it gets really interesting for me. How do they maintain that performance over that insane distance? How do you not break the 10 gigabit per second speed limit of the fiber itself? And what about that 4.2.0 thing you mentioned?
Ah, right. The 4.2.0 is the trick. It's the trade-off. Think of your video signal like a giant uncompressed photo. The card uses what's called near-zero latency chroma subsampling conversion. It's essentially, well, it's real-time compression. It intelligently reduces the amount of color detail, that's the 4.2.0 part, to make the data package just small enough to fit inside that 10 Gbps pipeline.
So you're shaving off a tiny slice of color precision to gain 20 miles of distance.
Exactly. It's a genius compromise. It's perfect for things like surveillance or data display, but you probably wouldn't use it for, say, high-end Hollywood color grading.
That makes sense. And I'm guessing to make that distance actually work, the specific hardware you plug in has to matter a lot.
Oh, absolutely. The critical component there is the SFP Plus pluggable unit. That's the little module that actually turns the electrical signal into light. And Kramer's very clear. To hit that 33-kilometer range, you have to use their certified 10 Gbp SFP Plus units. You can't just use any old part.
Right. If you skimp on that one little module, the whole system fails.
They'll lose the entire range.
Yeah. Okay, so sending the video 33 kilometers is one challenge, but how do you control the display when it gets there? I mean, what are you physically plugging into this card besides just the fiber?
So on the card itself, you have your 2 fiber inputs on standard LC connectors, but then you also have 2 RS-232 ports on these little screw-down terminal blocks. And that RS-232 is essential. It lets you send control data, the turn on or switch input command, over the very same fiber that's carrying the video.
And in these massive high-stakes installations, I imagine a source and a display failing to talk to each other is a total nightmare.
It is. A black screen over a 20-mile link is a huge problem. That's why this card has EDID Pro. It's Kramer's intelligent EDID processing. It basically forces the source and the display to shake hands and agree on the signal, so you never get that failure. It just works.
And for anyone listening who works on government projects, the TAA compliance is a big deal too. Makes it certified for procurement.
That's right. And to finish off the practical stuff, it only pulls 9 watts of power, which is incredibly low, and it comes with a 7-year Kramer warranty.
So when you put it all together, what are we really looking at? What's the bottom line?
The bottom line is this device solves a very niche but absolutely critical problem. You need rock-solid, high-bandwidth 4K video and device control in, say, a sprawling university campus, a secure government facility, or a huge transit system. Any place where the distance is non-negotiable and the video quality has to be perfect.
And that leaves me with a final thought for you to think about. Given that 33-kilometer range and the TAA compliance, could this simple 0.4-pound card be the critical link in a system that bridges the gap between 2 major command centers? Or maybe connects a remote observation post to a main control room separated by something as vast as a national park? The infrastructure required to even need this technology tells a massive story about who needs to see what from over 20 miles away. Something to think about until the next deep dive.